So what is the real difference between a junior developer and a senior engineer? It's not just about making the code work. It's about optimization. Hello everyone. I am Supratim, your coach at Techmine Guru. Welcome to our lecture 13 of our DSA series. Today, our mission is simple and powerful. We are going to tackle binary arrays, the election problem, and the 2D matrices, all while keeping our memory footprint at a strict O of 1 constant. So let's jump right into problem 1, the single flip. Imagine you have been given a binary array of zeros and ones. You are allowed to replace at most one zero with a 1. Your goal is to find the maximum length of consecutive ones you can create, right? So suppose you have been given this array 1 1 0 1 1 0 1, right? So if you replace the first 0 with a 1, you will get maximum length of consecutive 1 as 5, right? But what if you replace the second 0? The consecutive length will be 4 in that case. So our approach is to maximize the length. So the answer will be 5, right? So how to approach the same? The logic is pretty straightforward. You just have to check that how many consecutive ones are present in the left and how many consecutive ones are present in the right whenever you reach at 0. And once you get that, what will be the possible length? Number of consecutive ones in the left plus number of consecutive ones in the right. And since we are replacing this 0 with 1, it will add plus 1. So L plus R plus 1, right? So the approach is simple. You have to iterate through the array. Whenever you get A of I as 0, you will count the consecutive ones in the left of that 0, and you will count the consecutive ones in the right. And in the answer, you will try to get the maximum from the previous answer and the length of that array, which will be L plus R plus 1. So let's understand that with the code. So we have taken C is equal to 0, which will tell count of ones in array. So we ran a loop from I is equal to 0 to n minus 1, and we have checked if A of I is equal to 1, we will increase the count. So this loop will give us number of ones present in the array. And then we are checking one edge condition that if number of ones in the array is equivalent to the length of the array, that means that is the maximum length of the array we can get. Now coming to the actual part of the code, where I have taken one answer variable and I have started the loop, for loop, from I is equal to 0 to I is equal to n minus 1. And I have checked whether A of I is equal to 0 or not. And once I get A of I is equal to 0, I will take 2 pointers. Since I have to move towards left and right, 2 pointers has been taken and initialized at 0 0. Now for moving towards the left, I have taken a for loop from j is equal to I minus 1 to 0, right? Because we are moving towards the 0 from I minus 1th position. And we are checking if A of j is equal to 1, we will increase the L pointer, which will give us total number of ones present in the left. And as soon as we get a 0 somewhere here, we will break from the loop. So this for loop will give me total ones in the left. Similarly, for getting total ones in the right, I have taken a for loop for j is equal to I plus 1 to n minus 1, since we have to move towards the right. So for that, I have increased the right pointer whenever I get a 1 in the remaining array. And once I reach a 0, it will break out from the loop. So this part will give total ones in the right. And after we have moved from left and right, we are trying to maximize the answer with the max function, which will give us previous answer, comma, length of the subarray we got, right? Using L plus R plus 1. And we will simply return the answer. So what do you think? What is the time complexity? Since you are running a loop from for I is equal to 0 to n minus 1 till here, and inside that you are running 2 for loop. So the time complexity should be O of n square, right? But no, this is not the case here. So for that, we will take an example and we will try to dry run the same thing, that how the time complexity is O of n. So suppose our array contains 0, 1, 1, 0, 1, 1, 0, 1, 1, and 0. So if we start from this point, how many ones are there in the left? Since we have started the array from here, there will be 0 ones present in the left side. And how many ones are present in the right? 2. Similarly, for this 0, how many ones are there in the left? 2, right? And how many ones are there in the right? 2, right? So if we replace this 0 as 1, we will get 5 as the maximum length. Similarly, for this 0 also, number of ones in the left will be 2, number of ones in the right will be 2, and we will get length of 5 only. And for the last 0, since we have nothing in this array in the right side, so number of ones in the right will be 0, number of ones in the left will be 2 only, right? So the length is 3. So what is the maximum length? 5. But if you have observed, for every element, we are maximum going 3 times. Why? So let's understand that how we are visiting all the elements 3 times. So suppose we started from here, the left is 0, right? And the right will be 2, right? So we are moving it 1 time. When through I we are moving here, that is the second time we are moving here, right? And that time when we will come to this 0 again, that time we will move left side again. Since it was moved right side 1 time and left side again, so it is counted as 2. And since the I is also moving, so it is the third time for which we have moved for this 1. So how many times these 2 ones will be visited? 3 times. Similarly, for this 2 ones also we have visited 3 times, and same goes for this one also, we will visit it 3 times. So what will be the total iterations? It will be 3n. So our final time complexity will be O of n only. So what is the lesson here? So if there is a break in any loop, you have to calculate time complexity carefully. You cannot see that we have an outer loop, we have an inner loop, and the time complexity should be O of n square. This should not be the case, because in this, after evaluating and checking properly, we found that the elements which are 1 are getting visited 3 times. So the total iterations is becoming 3n. And so the time complexity is O of n only and not O of n square. So I've also mentioned the lead code link in the description as well. So you can check it later as well. So let's understand the second part of this problem. What if instead of replacing, we can only swap from one of the ones in the array, because of which it will become 0, and one it is getting replaced will become 1. And the main problem statement remains the same. We have to get the maximum length of consecutive ones, right? So what is the catch here? So the catch is, to swap, you need one extra one available in the array, because in this you cannot replace the 0 with an extra one. You have to take it from the array itself only. So it's like swapping. So the main logic remains the same, but there will be a little change in the conditions. So if you see in the code, I am trying to check how many ones are present in the array. And for that, this is like one approach and this is like another approach without using if condition. Because since the array has all 0 and 1 only, if we count all the elements of the array, that will give us the count of ones in the array only. And you can use shortcut like this as well. Again, this is the edge condition where I'm checking if the count of ones in the array is equal to the length of the array. Then we have got the maximum length sub-array sum as the length of the array only. So as we have already seen the above logic, this logic remains the same. We are iterating a loop from for I is equal to 0 to n minus 1. And whenever we are getting a of I as 0, we are taking L and R 2 pointers. And we are again iterating from j is equal to I minus 1 to 0 to move towards the left side. This part will again give us total ones in the left. And whenever we are not getting a of j as 1, we will break from the loop. And similarly, we are doing for the right side by taking the for loop from j is equal to I plus 1 to n minus 1. And whenever we are getting any one, we are increasing the right pointer, which will give us total ones in the right. Till now, once we are out of this loop, we will get our L and R. If L and R is equal to number of ones in the array, that means we don't have any spare one present, right? That time our answer will be max of answer comma L plus R. And suppose if L and R is less than C, that means we have one extra one present in the array, right? Which we need to swap it there. So for handling that, the formula remains the same, which is answer is equal to maximum of previous answer comma L plus R plus 1. So this is also a lead code problem. The link I have given in the description as well. Now let's move on to the voting problem, the majority element. In this problem, we need to find the element that appear more than n by 2 times, which will be called the majority element. So suppose we have given the example as 3, 4, 3, 2, 4, 4, 4, 4, 4. So how many 4s are present? 5, right? And is it a majority? Yes, because the length of the array is 8. So 8 by 2 is 4. So 5 is greater than 4. That means 4 is the majority element. So how we can solve this? We can solve this using some brute force approach. But again, the brute force approach will give us O of n square. Also, we can solve this via hash map. But we have not used hash map till now. So we will ignore this one because it will give us O of n space. It will not give us O of 1 space. And also, we can do sorting as well, which will bring all the elements consecutive to each other. And in that way, we can count. But again, sorting internally will take O of n log n time. So again, we don't want this approach as well. So let's see how we can solve this in O of n time and in O of 1 space. So let's start with an intuition. So suppose there is an election going on and these are 3 candidates. Kavi is one of the candidates, Dipankar is one of the candidates, and Vivek is one of the candidates, right? So suppose Kavi got 9 votes and Dipankar got 2 votes and Vivek got 4 votes. So what is the total number of votes? 15, right? But since Kavi has got 9 votes, so Kavi is in majority and Kavi has won the election. So suppose after some time, we get to know that 1 vote from Vivek and 1 vote from Kavi has been disqualified since they were underage. But will it impact the election result? No, right? Because now Kavi will have 8 votes, Dipankar will have 2 votes, and Vivek will have 3 votes. So total votes will be 13, whose divided by 2 will be 6. So since still 8 is greater than 6, still Kavi has won the election. So did you understand what is happening? So in this, the main idea is that if we cancel out 2 distinct votes, the majority winner remains the same. So this is also called Boyer-Murray's voting algorithm. So what has been done in the code? Let's see that. So first of all, you have to find the candidate and then you have to verify that how many times that candidate came. And if the count is greater than n by 2, return the answer. Otherwise, there is no majority. So before understanding the code, let's understand that with this dry run. So I have assumed that the first element is the candidate. And since we got element, we have taken a frequency variable and set it as 1. Now we are starting the loop from here, right? So right now in our answer, 3 is the majority element and it has frequency 1, right? Now we are starting the loop from I is equal to 1 to n minus 1, where we are checking for this one. Since our frequency is 1, we will come to this block where A of I, which is 3, is equal to the answer. So we will increase the frequency from 1 to 2, right? That's what we have done. Now we will move to 4. Since frequency is 2, this block will not work. Since A of I is not equal to answer, this block will also not work. And this will work. Since this is the new candidate, it will cancel out one of the previous candidates count, right? So the frequency becomes minus minus, and now the frequency is 1 again, right? Similarly, when we will move to 6, since the frequency is 1, this will not work. Since A of I is not equal to answer, this will also not work. Now the frequency will become 0 again, right? Then we will move to 1 because this 6 will again decrease one of the frequency of the 3. Since frequency is 1, so in our answer, now 1 will be stored and its frequency will be set to 1, right? 1 will be set as the answer and the frequency will be 1. Now again, we are moving the array. It will come to 3. Since the frequency is not 0, this block will not work. And since A of I is not equal to answer, because 3 is not equal to answer, in our answer, 1 is present. So this block will also not work. And now this else block will work because this 3 will decrease the frequency of this one. So again, this 1 will set to 0. Now again, 2 will come, but this time frequency has decreased from 1 to 0. Since the frequency is 0, the answer will have 2 instead of 1, and the frequency will be set as 1, right? Now again, we will move to the array. We will get 5. Since frequency is not 0, this block will not execute. And also A of I is not equal to answer because in answer 2 is there, but A of I is 5. So this will also not work. And this will work because this 5's arrival will decrease the frequency of the 2, right? So the frequency will decrease. Answer still same. Now we will again move to 3, next element. Since the frequency is 0, we will again set the answer is equal to A of I, which is now again set to 3, right? and we have set the frequency as 1. Now we will move to this 3. Since the frequency is 1, this block will not work. Since a of I is equal to answer, because answer has 3 right now, and a of I is also 3, the frequency will increase from 1 to 2, right? For this 3. And similarly, for this 3 also, frequency of the answer will increase from 2 to 3, because this block will only get executed. So once you come out of this for loop, you will always have the element which is in majority. But now you have to check whether the majority element which you received as an answer is present in more than n by 2 or not. So for that, we are again simply iterating throughout the array again, and we are checking whether how many elements are present for that majority element. So this is how we are calculating the frequency of majority element present in the array, and for this it will give 6, right? Since we have 3 6, 1 this one, 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 and 1 this one. So C will be 6 now. Since 6 is not greater than 13 by 2, which is 6 again, so there will be no majority, right? So this is also a lead code problem. The link I have given in the description. So finally, let's move on to the last problem of our day today, which is set matrix 0. So you will be given a 2D matrix, and whenever you get a 0 in the 2D matrix, you will make all its row and all its column as 0. So how will you approach this? So this should be the resultant matrix. So you can start thinking that once I get 0, I will mark this as 0, mark this as 0, mark this as 0, mark this as 0. But this will not work. Why? Because what if there is already some other 0 also present? So we have to mark it some different way. Also, you cannot use a separate Boolean array as well, because the requirement is you have to solve the problem in O1 space. So let's use this matrix only to store the state. So the idea used to, we have to take -1 as a temporary marker for each cell that needs to turn to 0. And this will prevent the structure without confusing future iteration, that whether because of this 0 they have become 0, or whether they were already 0. So we will not get confused because of that. So the implementation is pretty straightforward. So in this, you have to one time go through row wise, which you have already seen in your previous classes, going throughout the matrix in row wise, and one you have to go by column wise. Why? Because when you go through row wise, that time only you will be able to mark the complete row of that particular element as -1, and when you go through column wise, then only you will be able to mark all the elements of that particular column as -1. So for this part is done for row wise, where I have taken a loop from for I is equal to 0 to n-1. I have taken a flag as false, which will be on whenever I get a 0. So this for loop will iterate through the column. So whenever we reach a of I and j is equal to 0, we will mark the flag as true, and we will break from this loop, right? And once we break from this loop, we will check if flag is true or not. If the flag is true, then we will again iterate to all the columns of the particular row, and whenever we will get non-zero element, we will convert it into -1. And same thing we have to do when we are iterating column wise. So for that, I have taken a loop for j is equal to 0 to m-1, and inside the loop, I am going row wise. So this will tell that in this particular row, any element is 0 or not. Once we reach a 0, we will make flag as true, and we will break. If the flag is true, we will iterate throughout the column, and we will mark all non-zero element as -1. So this is the part of the column wise iteration and marking all the non-zero element as -1 whenever we reach a 0, right? But lastly, we have to convert all -1 to 0. So for that, again, I'm starting a loop from for I is equal to 0 to n-1, and inside that row, we are going through all the columns, for which for j is equal to 0 to m-1, we'll do that. And since we have marked all the non-zero element of that particular occurring 0 element as -1, so whenever we get a -1, we will assign back it to 0. So what is the time complexity? The time complexity will be O of n cross m, and since we are not taking any extra space, the space complexity is O of 1. So this is also a lead code problem. I have mentioned the link in the description. So today we learned about sliding logic, that how to use left and right pointers and to avoid nested loops. Also, we understood how voting problem or the majority election problem gets solved using arrays, in which we approached it via cancellation method by pairing distinct elements to find majorities. And lastly, we have taken a 2D matrix where whenever we get a 0, we set all the elements of that row and column as 0. And we saw how we used in-place markers like -1 to save ON space and to solve the problem in O1 space. So if you found these patterns helpful, hit that subscribe button. In our next lecture, we will be diving into even more complex 1D array problems. With this, I am Supratim signing off for today, and I'll see you in the next one. Till then, keep coding, keep optimizing, and keep learning.